Carbon has 2 electrons?
Yeah, it has double bonded with oxygen.
Double bonded with
And
oxygen?
it has 4.
And oxygen has 4 electrons?
Because then the normal charge would be 0.
Okay. That looks good.
But then it doesn't make enough sense. Because if you were to go one more, then C would have a minus and the oxygen would have a plus.
Yeah. So if you stop here, then it's 0 formal charge and 0 formal charge. So, but the problem is with the octet rule. Oxygen has an octet, 2, 4, 6, 8, but carbon doesn't. Carbon is 2, 4, 6. If we did one more, like you mean a triple bond?
Yeah.
And so we take one off there and give it, then you're right, the formal charges are very weird here because oxygen would go plus and carbon would go minus. And so what's more important? What's more important is getting an octet or formal charge. And so over here, what was more important was formal charge, that didn't work. And that was because of fluorine. But in this case, what is the structure for carbon monoxide? Let's take a look. Let's see what we can find for what do you see for carbon monoxide? Triple bond. The triple bond. Carbon monoxide is this, you wouldn't expect it because, this means that oxygen has to give up an electron to carbon. But when we look at the electronegativity, let's take a look at the electronegativities again. Here. Maybe it isn't as bad. Maybe it is. Here, oxygen is 3.4, carbon is a 2.6, so the difference is 0.8. So 0.8 is that a huge difference? No, it's not as bad as this one, which was a 2.0 difference. This is a 0.8 difference. And so in this particular case, it is. This is one of the reasons why carbon monoxide has some very interesting properties. It's because the carbon has a negative charge on it, and that makes it behave differently. So this is actually the structure here. And so this is a case where it kind of bucks what we just talked about with BF3. Carbon monoxide doesn't follow that same pattern there. Carbon monoxide is a different pattern, but oxygen is different than fluorine. So this is why I say fluorine is unique in the sense that it won't, but oxygen will in this case, as it does in carbon monoxide. We see oxygen with a positive formal charge in other species as well. So for example, this, you know what this is called? H3O. Well, what are the formal charges here? On hydrogen, is there any formal charge on hydrogen? No. Oxygen, is there a formal charge on oxygen? Yes. What is it? It's plus. This whole thing carries a positive charge. This is called H3O plus. That positive charge is on oxygen. Oxygen is a formal charge. And so it's not terribly unusual to see oxygen with a positive formal charge. It would be very unusual to see fluorine with a positive formal charge. That would be unusual. But here there's precedence for this. And so this is the case where it is weird because I would expect the negative to go on oxygen and the positive to go on carbon, but here it's flipped. And the reason it's flipped is because the octet. Trying to establish the octet is more important in this case. Okay. do some more here. Let's go on to number 4. NH4 plus, what's that? Ammonium. So we'll go through these quickly. Ammonium, nitrogen's 5, 4 hydrogens, it's 4 electrons, and then a +1. When we have a +1 charge, do we remove an electron or add an electron? We're going to remove an electron, so -1 electron. So this gives us a total of 8 electrons. And then hydrogen can only form single bonds like fluorine. Fluorine and hydrogen only form singles. And then actually this structure takes up 8 electrons, and then we're good. So this is in step 5. Then we go to step 6, which is formal charge. So what are the formal charges here? Yeah, all the hydrogens are 0. Actually, we normally don't show the 0. We just show non-zeros.
Plus on nitrogen.
Yeah, plus on nitrogen. So this whole thing is positive charge. It's the ammonium ion.
How would you know which is what charge?
How would you know which is which charge?
Negative, positive, how would you know the negative would be the hydrogens?
Well, negative means you have extra electrons. Positive means you're missing electrons. Electrons themselves are negatively charged, so if you have an extra electron, it's going to lead to a negative charge. Let's take a look at the next one, pH 3. pH 3 is phosphine. Phosphorus is 5 electrons, and 3 hydrogens is 3. So again, this is going to be 8 electrons. And so we'll put phosphorus and then 3 hydrogens bonded to it. And then we'll complete the octet in one pair. So when we do that, we have 8 electrons. And what are the formal charges here? They're all 0. That's correct. There's no formal charges there. And then the next one is NHF2. NHF2. Nitrogen's 5. Hydrogen is 1. Then 2 fluorines is going to be 14. Fluorine 7. No charge. So this is going to give us 20 electrons. Now fluorine never forms more than 1 bond. And so we'll throw in nitrogen in the center here, and then we'll attach, let's attach a hydrogen and then 2 fluorines to it. And then we're going to complete the octet. So we'll complete the octets to fluorine first because it's the most electronegative. And then we'll complete the octet to nitrogen last. And so everybody has an octet except hydrogen, which has a duet. And so if we look at the formal charges, what are the formal charges here? They're all 0. All the formal charges are 0. And everybody has an octet, and so we're good. Octet and formal charge is good. So we'll stop there. Okay, let's take a look at this next structure, BRO minus. What's BRO minus called? BRO minus is called hypobromite. Hypobromite. Bromate is BRO3, bromite is BRO2, therefore hypobromite must be BRO. So hypobromite ion, bromine, 7 electrons, oxygen, 6 electrons. A -1 charge means +1 electron. So it's 7, 7, this is going to be 14 electrons altogether. On this one, we can only come up with one kind of structure, and that's going to just be Br bonded to O. Br bonded to O. Well, which one are we going to complete the octet to first? Oxygen or bromine? We're going to complete it to oxygen first. Okay, and then we'll complete it to bromine. And so how many electrons have we used? Well, actually 2, 4, 6, 8, 10, 12, 14. 14 and 14, that's correct. That looks right. How about the formal charges? Everybody has an octet. We used up 14 electrons. How about the formal charges? Negative for which one? Well, bromine's supposed to have how many? 7. So in this structure it has 2, 4, 6, and then 7. So it has 7, it's supposed to have 7. Oxygen's supposed to have 6. How many does it have? 7. So that means the negative goes on oxygen because it has an extra electron. And so hypobromite, we add up the formal charges, we get this. That's it. Everybody has an octet. Now, that's an even number of electrons, but sometimes we have an odd number of electrons. So let's take a look at when we have an odd number of electrons. For example, carbon monoxide had an even number of electrons. Hypobromite has an even number of electrons, but nitrogen monoxide, NO, has an odd number because nitrogen has 5 electrons, oxygen has 6 electrons, and then there's no charge, so we end up with 11 electrons. If we get 11 electrons, then what does that structure look like? Well, we're going to have nitrogen bonded to oxygen. Then what we're going to do is we're going to fill the octet. Which one do we fill first, nitrogen or oxygen? Oxygen. Oxygen is more electronegative, so we'll do that one first, and then we'll do nitrogen. So now everybody has an octet, right? And so that should be good. That's kind of like this. Everybody has an octet. We're good. Except now let's do the electron count. If we do electron count in this structure, what do we find? How many electrons do we have here? We got 2, 4, 6, 8, 10, 12, 14 electrons. But how many electrons do I have? I have 11 electrons. And so that means I'm going to have to remove electrons. I have 3 electrons I need to remove. So who should I remove them from? Probably nitrogen. Why nitrogen? Because nitrogen is less electronegative. But that's going to leave nitrogen without an octet. And so oxygen's got to help out now. How can it help out? Yeah. And so what I'm going to do is I'm going to, now I'm going to take this pair and bring it into the bond. So I'll get a double bond here. Like that. Oxygen still has an octet. The formal charge did change. Because up here, what are the formal charges? So nitrogen has what formal charge? This is the correct number of electrons, 2, 4, 6, 8, 10, 11. Nitrogen has 2, 3, 4, so it's plus. Oxygen is 2, 4, 6, 7, so it's minus. So if I do this, what happens to the formal charge? Yeah, it's going to go 0 and 0. So this is good. But there's still one more problem with this. Oxygen's fine, it has an octet, but nitrogen, does it have an octet? No. And so what we might try to do is we might try to form a triple bond. Drop that. We form a triple bond like this. This is kind of like carbon monoxide. You know, carbon monoxide was trying to help out. Oxygen was trying to help out carbon. Well, nitrogen is even more electronegative. So maybe it does this. But there's one major problem with this. What are the problems? Well, the problems with this are that the formal charges, what would the formal charges here be? Nitrogen would be minus and oxygen would be plus. Is that really a problem? We saw that before in carbon monoxide. And so maybe that's okay. However, there's a bigger problem. What's the bigger problem? more than an octet, 2, 4, 6, 8, 9. And so second period, or second shell elements, carbon, nitrogen, oxygen, fluorine, cannot expand their octets, cannot have more than an octet. And so nitrogen's always going to come out short here. In this case, this is not going to work. And so we can have below an octet, we cannot have more than an octet for nitrogen. But the next example, it's even more readily apparent, because if we look at the next example, which is NO2, and so let's do NO2 really quick here. NO2, nitrogen is 5 electrons, and then we have 2 oxygens. This is going to be 12 electrons total. So this is going to give us 17 electrons. So I'll put nitrogen in the center and then 2 oxygens, and then I'll complete the octets. First to oxygen, and then to nitrogen. And how many electrons have I used up? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That's 20 electrons. I have to get rid of 3. And so what 3 am I going to get rid of? Nitrogen. So let's get rid of 3 electrons on nitrogen. But there's a problem here, and the problem is this. Nitrogen does not have an octet. So I'll pick a pair of electrons and drop it into the bond. So what I'll do is I'll come up with this structure here. Okay, now it's getting closer. And so what are the formal charges I have here? Well, what were the formal charges here? Do you see it? Minus, plus 2, minus. Over here, this is 0, plus 1, minus 1. And so these are neutral molecules. And so it might end up like that, or I might try to form 2 double bonds. What if I form 2 double bonds? Would that be better? Because that will get rid of this formal charge. If I just form one more double bond, I can drop the formal charge. Now what are the formal charges? The formal charge on this oxygen is 0. What's the formal charge on this nitrogen? 0. And this oxygen? That looks good. And so what I should do is I should just, nitrogen, the only problem is nitrogen is going to have more than an octet. It's going to have 2, 4, 6, 8, 9. And so that's a negative. The positive is all the formal charges go to 0. And so everybody gets an equal share of electrons. Whatever they contributed. But this can't happen. Why? Even though I'd like to do it, I can't, because nitrogen cannot have more than an octet. And so I'm stuck with this. I'm going to have less than an octet on nitrogen here, and then I'm going to have these formal charges here. So I can't have this structure. And so that's what's shown over here. Nitrogen does not expand its octet. Whereas if it were phosphorus, phosphorus is right below nitrogen. Phosphorus can expand its octet. There's not a problem with that. But nitrogen cannot. Okay, we're going to take a break here, and then we'll start up again after the break.